All right, we're going to go ahead and look at an exponential equation and how we convert it back to its recursive rule. So let's find the first four terms of the sequence and the recursive rule. So it gives us this exponential function, y equals to negative 10 to the 3x, and it does this in function mode. And then what it does is let's find the first four terms of the sequence. So what it's actually asking us to do is just simply say, okay, well, let's find number one, the first term, the second term, the third term, and the fourth term. So these are terms. And in order to do this, we're just simply going to plug these values into our exponential equation. So for example, negative 10 times 3 to the first power. What is negative 10 times 3 to the first power? 3 times 1 is just 3, so it's negative 10 times 3, which is negative 30. So I'm going to come over here and say, well, I know that the first term is negative 30. Now we go to the second term. It's just the exact same thing. I'm going to say negative 10 times 3 to the second power. Well, 3 squared is 9. So negative 10 times 9 is negative 90. And then we just keep going. Negative 10 times 3 to the third power. Well, 3 to the third power is 27 times negative 10 is negative 270. Now, some of you may have noticed, well, guess what? We've been doing this for the last couple of days, and I recognize that all I really have to do is once I get the pattern started, I'm just multiplying by 3 every single time. So really, I just need to take negative 270 and multiply it by 3. That's the purpose of these sequences. They tell us easy ways of doing things. So what is negative 270 times 3? It is negative 810. So negative 810. However, if you felt comfortable or in just following the pattern of using the exponential table, we do negative 10 times 3 to the fourth power. 3 to the fourth power is 81, so we do negative 10 times 81, which is negative 810. But we can follow that out. Now, let's go ahead and write our recursive rule. So we would start by saying, well, what was our first term? Well, our first term is a sub 1, and that is equal to negative 30. Okay. And then we would say, well, a sub n, which is our next term value, equals to a sub n minus 1, which is essentially the value of the term we have now. But what are we doing every single time? We are multiplying by 3. That is our common ratio. Okay, common ratio. Okay, and we're saying a sub 1 equals negative 30, a sub n equals a sub n minus 1 times 3. Now, there is another way we could do this. This is one recursive rule that we could write for this, but I'm going to go ahead and look at the exponential equation that we have written here, because some people may be saying, wait a second, do we have to write it from the first term? Guess what? We actually were given a sub 0. A sub 0 is negative 10. It's in the exponential function. So I could say, well, you know what? We started with knowing the 0th term. The 0th term comes right out of the exponential equation, and that is negative 10. So is it okay for me to write it as a sub 0 equals negative 10? Absolutely. Doesn't make a difference. We were given that information, so let's write it that way. So a sub 0 equals negative 10, and then we just write the exact same thing. What we have next. In order to get what we have next, we need to look at what we've got now, and we need to multiply it by 3. So we have two different ways we could write it. In this case, we could write it from our first term, but we could also write it from our 0th term since it's given to us in our exponential function. All right, I hope that helps you out. We started with an exponential function, and then we went back to our recursive rule. You'll have a great day.